You've got stuff for me.
Greatest hits. That's bang.
So to answer your question, read my pen and think at the same time.
Okay. You all got a copy of this on Sunday. This is what my next couple of days looks like, and that's where we are now, and that's us tomorrow. So as you can tell, I will end one exam and start the next one. So I'll be coming in with this thing. So y'all should eat before the exam, so I don't drive you crazy standing up here eating. And that means that this is basically, what do you want to know about the exam? All on you. Talk to me. It's almost exactly equal between the four sections. So exam 1, exam 2, exam 3, and new material. I don't have the exact point breakdown in my head at the moment, but I wrote it with everything broken out roughly.
Is there going to be theory like the other exams, or is it going to be more like math?
There'll be some of the theory questions in there, but as much theory as you've already seen. I don't ask a lot of proofs in this course. This is really more of a how course than a why course, most of the time. Yes, Brad.
On that chart you had a second ago, it said, just to make sure it was 1 to 3?
Yes.
Tomorrow. Okay.
1 to 3.
In this room?
Yep, right here. The only thing that's different is I'm going to spread y'all out.
Sure.
Like a hard, cut off at 3?
Like with the last exams, I'm going to give you a couple minutes, but I have a meeting after that, so I don't get to go home and start grading. Well, the big problem is, I have seniors in this class, I have seniors in this class, I have seniors in this class, and senior grades are due here, and my parents arrive then, and my in-laws arrive here, so I'm going to be busy as Go hard 3 o'clock? No. I still have to be here for another hour, 2. What other questions do you want to hear? Review sheet, other exam questions, other stuff.
Could we look at some question that deals with like the kernel of an operator?
Okay, so the kernel of an operator is the set of vectors that get mapped to 0. So it's the null set for that transformation if we're dealing with a matrix transformation. If we're not dealing with a matrix transformation, then I'm going to have to figure it out from the description. So if I'm looking for the kernel, if I have a matrix, I'm doing a null space. Where the null space goes with the matrix associated to that transformation. If I have a description, I'm going to have to look at this equation. And I think the one we did in class was about like functions. We talked about a transformation from the set of continuous functions whose domain is R. And I said that the transformation of f of x was f prime of x. Well, that doesn't have a matrix that goes with it, but I can still ask the question, What functions satisfy that? Well, the zero vector is the equation 0. So what this is really asking is what functions satisfy f prime equals 0? Everywhere. Not just for 1x, not just for a couple of points, but which functions are always have their derivative always equal to 0? Calculus was a long time ago, man. But something is derivative of 0 would be any constant. And that means that the kernel of this transformation is the set of constant functions. When it comes to a matrix creation, I'm just doing a null space. So we know we've done that like 8 different ways. So I got that part made.
Yeah.
Better?
Yeah, thank you.
Welcome. Kernel is null space. Range is column space. Or row space, if you were dealing with an operator, it goes from itself to itself. So that's why we get the columns with the pivots and the columns without the pivots. Without the pivots gives me the null, with the pivots gives me the column. So we have rank and nullity. Those play the dimensions for those same things. More questions?
I don't know if this is one you can really answer, but is there anything that we don't need to focus as heavily on when reviewing stuff compared to other things?
I'm going to stick with the statement I made earlier. It isn't a theory-heavy exam. You will have seen a variation on every problem that's on the exam. Whether you've seen that exact problem or something close to it, you will have seen all the problems. I'm not going to pull something out of thin air that you like, where did this come from? I said this to one of my classes earlier today. The final exam is not my opportunity to fuck you over. I've been doing that all term long. So at this point, it's your chance to get back at me and say, no, I really do know this here. And that's what I want. I want to write an exam that pushes you, but doesn't shove you out a window. And say, okay, you do know this. Demonstrate that to me. Here's familiar enough things. The worst feeling in the world is to give me the exam, walk out the exam and go, shit, that's how you do number 3. So I want you to be sitting in here going, yes, I do know how to do number 3. Here you go. Yes, I do know how to do number 6. Here you go. But number 3 here is like number 7 from exam 1, so you've seen it, or it's like this one that was on the homework from chapter 7, section 3, and that's number 19 or something like that. All of a sudden, yes, I know I have done this problem before. I really don't want to shove something and go, okay, here, let's do a singular value decomposition. You have to have the entire process memorized. Go. Here's your homework question. Do your exam question. Do a 5-dimensional Graham-Schmidt process.
That'll be a bonus question.
Only if you want me to be sick all over the page watching you do it. God, no. A number of years ago, this class was more theoretical. We spent a lot more time on the abstract vector spaces than on Rn. And I actually did Gram-Schmidt process in the space of polynomials, which means you changed from the dot product to a different product. The product required integrals. So I had a linear class, and the bonus question on that final was do the Gram-Schmidt for 3 functions. And they were all looking at me like, you expect us to remember how to integrate? It's all gone. Sorry. That's the sort of stuff my grad school class did a lot of. Why would I do that to you guys? More, yes, sir.
Is the layout of the questions, is it like chronological or are they completely random?
Oh, no, it's in order
Okay.
Yeah. from January to now,
Yeah.
in order on the exam.
Okay.
Which means maybe you start at the back and work your way backwards. I don't know.
Exactly, yeah.
You figure out where you want to start.
That may be best, or at least, yeah.
I say that, and then I remember that the unfortunate part about this course is that all this builds on itself. So, hey, what do I need to do here? Row operations. Crap. I need to remember how to do that. What do I need to do here? A determinant. Right, like we're doing back there and back there. Lots of places where the same pops up.
Yeah.
I was on Instagram the other day. I saw a short reel, and it was, we're going to do second semester physics in 1 minute. Ready? Go. And on one of those panels of the chalkboard, so not a very big panel, he wrote down every single thing you cover in E&M. And it was just 4 columns. Somebody said, well, what's linear algebra? And I said, really? It's reduced row echelon form, invertibility, inner product, vectors, and transformations. 5 columns. That's it. Everything else is based off of that. A singular value decomposition. Well, that's an eigenvalue eigenvector problem. That's in the matrix section. Off we go. All lines up on each other.
Could we talk about a problem where it's like the dimension of a certain vector, or I'm sorry, matrix?
Dimension. Well, matrix dimensions are the size of the matrix. So when I say that a matrix is 4 by 3, that's 4 rows and 3 columns. Those are the dimensions of the matrix. But do you mean the matrix spaces, like row space and column space and things like that? Or do you mean the dimensions of the size?
Believe it or not, I guess I meant more dimensions of the size, which is, I guess, pretty self-explanatory. But
Well,
I don't necessarily point on it.
No.
So I was wondering.
It's always R by C, rows, columns.
Okay.
So if you have a 7 by 8 matrix, that's 7 rows, 8 columns.
Okay. Cool.
That's always the tag. You go back and you go, all right, what did I last time? How do I not do that again? This is what I've done in every class today. People ask me a question. I didn't bring anything to do. From this section. I think that's a 7. So 5.5, number 7. So there's my lambda I minus A. So when I do the determinant to get my characteristic polynomial, I have lambda minus 3 root 3. Are those both positive? Yeah. Minus negative 1 is plus 1. So that's lambda squared minus 2. You know what? I'm not even going to bother to multiply it out. Because my goal is to set that equal to 0, right? So lambda minus root 3 squared plus 1 equals 0. Lambda minus root 3 squared equals negative 1. That's where I take my square root. Lambda minus root 3 equals plus or minus the square root of negative 1 is an I. So I get lambda equals root 3 plus or minus I. Now, it says write this as a rotation and a scale factor, right? So what that means is that I need to know how to get this in that cosine and sine setup. And it says in the book I should use the one with the negative on it. So square root 3 minus I. I want to know what that angle is. I want to know what this length is. But this side of that triangle is root 3. This side of that triangle is 1, and that's a right triangle. What's this side? Pythagoras. Root 3 squared plus 1 squared, all square rooted. Square root of 3 plus 1 is root 4, that's 2. The angle here tangent is opposite over adjacent. Now that's negative 1 because it's going down. What's an angle whose tangent is negative 1 over root 3? Trig was a long time ago. Or minus pi over 6. I can go backwards instead of going around the long way. So the rotation setup shown on page 300 and where is it? (307). Says that the breakdown should look like this. The one matrix on the left, that's an expansion or contraction. That's the real part. That's this length. So in our case, this is R, and this is phi. So I get 2002, and then cosine of minus pi over 6 is root 3 over 2. Sine of negative pi over 6 is negative 1/2. And then these are positive 1/2 and root 3 over 2. So the whole deal here is to convert between X, Y coordinates, and polar coordinates, R and theta. As I used here. Better? It's this piece that's the part of it. Now, what I could do is I could then use that with the eigenvectors, and that's what we did in the next set of problems on the homework there. So that means if I use this matrix, and I look at that forward orbit idea, I should see points that are going around and getting bigger. Because this says each step should go more 30 degrees more negative, and each step should get further out by a factor of 2. So I'm going to get this outward spiral going clockwise. Right? More questions? That shows up more in the differential equations course than it does here. I will post the keys to the review sheet and to the homework immediately after class. So you'll have them to study from. Since of all the stuff I collected today, yours is the first exam in that pile, so I'm grading your stuff first tonight. Collected a lot of other classes too.
Can you read a bonus on this exam?
Yes.
Would that be similar to the discrete bonus or similar to
To the discrete bonus. I don't remember the discrete bonus.
last year? I believe the discrete bonus was
Oh, I get. I'm going to go with it's more likely you'll get an actual bonus question in this class than a tell me how the course went. Far more likely. This is what I get for writing your exam last week. I don't remember. I have no reason to leave your butts nailed to this chair. So if you don't have questions to ask me, I don't have a reason to keep you here. Which means go home and study. I will see you all tomorrow. Have a wonderful rest of your day and an easy exam week from here on out. What I will do is I will post the keys right now.